Okay, in this video, I'll talk about how a cis versus trans fatty acids create an issue in terms of really the bonding and in terms of the orientation and how their melting point affect in that case. So here I have an oleic acid, which is an cis double bond. And if you count the number of carbons in there, oleic acid has 18 carbons. So this is actually going to be 18 one means got one double bond in there. And where that double bond is, if you want to look at it, that would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is like an omega 9 here. Now this is a cis, so you can kind of see how a kind of kink is produced in here. So if I get another molecule of this, it's going to have a hard time to stack on the top of that. But when you look at the trans, on the other hand, so the trans, this particular one is an elydic acid here. It doesn't really have any kink. It's kind of in a straight line, just like you would see in a saturated fatty acid. So it does not have any issues with the stacking. If I get another molecule of this, like I'm just giving an example. Let's say I kind of copied this, and let me go ahead and paste another one of this. Ooh, yeah. So if I paste another one of these, like right there, it will stack right on the top of that. But that's really not going to be an thing when you actually look at an cis fatty acid in that particular case. So typically, as a result, they these guys, whenever you have a fatty acids, relatively speaking, they will have lower melting point, and sometimes it's low enough where it goes below room temperature, so they are going to be very likely oil, or you can say liquid room temperature. But when you have just the trans fatty acids typically have relatively or higher melting points for the same number of carbons, you can say, and sometimes their melting point is high enough where they may be solid. If it's over, let's say, 25, then they would be solid at room temperature in that particular case. If I want to tell you what the relative melting point is going to be for these guys, so the oleic acid is actually going to be 14 degrees Celsius. So that will be oil at room temperature. That's because of room temperature is around 20, 22, so 14, that's below that. So on the other hand, the melting point for this transylidic acid is actually going to be about 45. So that will put it well above the room temperature. So that would be in a solid in real life or at room temperature, and this would be a liquid. So this is what you really want to know and take home as how does the cis and trans fatty acids and how their configurations affect their physical existence in nature. I can look at an example here. So let's look at this particular one where you have stearic acid. All right, so stearic acid, remember it's 18 carbon, so 18, 0, there's no double bond. It is a saturated fatty acid. Its melting point is 69. That's because the long hydrophobic chain that you got in there. And if you get multiple of these stearic acids, they will stack on the top of one another with no issues. It's like stacking these chips right there. So when they stack really well, they are going to be making these hydrophobic interactions really well with one another, and it's going to be hard to break those. As a result, you would need a higher temperature to melt it. But let's look at this oleic acid. So remember, the oleic acid is also going to be 18 carbon, but it just has one double bond in there. And that happens to be the cis in this particular case. So that cis double bond, you can kind of see how it's kind of creating the kink in there. And so when you try to put together multiple oleic acids, they will not really stack on the top of one another that well. And as a result, it kind of creates a lot of holes in there or empty space where they're not really making a lot of interactions. So as a result, it's going to be really easy to melt this. And when we are melting this, we would be needing relatively lower temperature. So the melting point for this oleic acid is about 14 degrees Celsius. So you can kind of see how if you just throw it all the chips So this is more like Pringles, I guess. They kind of stack on top of one another, but these are just regular chips. When you just put them in a package here, they're just going to be here and there, not really well packed, and that's exactly what's really happening with these cis fatty acids, and as a result, they would have relatively lower melting points.